My dissertation is entitled Visual Analysis of Multi-Attribute Choice, and it centers around visualization tools that support the specific needs of experts who make complex decisions based on large data sets in their daily work, for example, in engineering or politics, let's say. As key contributions, I was able to provide new methods to systematically understand and also describe real-world data-informed decisions, including a novel type of problem, and to use these gained insights to design 2 visualization tools that allow decision makers to apply their professional judgment, their subjective judgment, as they learn what outcome, what decision performance is achievable under what conditions. So existing decision support tools helped decision makers understand the data, but rarely provided dedicated support for decision activities like constructing preferences or balancing criteria. So my goal was basically to bridge the gap between the data-centered optimization and the subjective human judgment. I started out by observing the target users in their natural daily work environment, and then I connected these observations to models and concepts from decision theory and cognitive science to really systematically capture the requirements of these real-world decision problems. And then based on these requirements, I used established methodologies from visualization research to design helpful tools that enable an interactive exploration and an individual balancing of these decision options and also their consequences. And with these tools, I then went back to the field to make sure that they in fact provide the claimed decision support. For example, engineers are now using one of my tools for multiple years for their daily work to design customized electric drives for specific applications. So these contributions basically bring a new emphasis on decision processes that were previously underrepresented in applied visualization research. My findings help to shape the general understanding of making decisions with large datasets and how to support these decisions with visualization. I imagine my findings to be helpful also in other domains where complex decisions need to be taken based on a lot of data, a lot of options that are characterized by multiple decision criteria. Yeah, so first of all, let me say that I feel very honored to receive this award, and I would like to take the chance to thank the Fraunhofer ICT group for acknowledging my research in that way. I think in particular in times where people and also processes increasingly tend to employ and also partially rely on artificial intelligence, it is critically important that we acknowledge the unique abilities that we as humans bring to the table and that we do our best to create environments where humans and algorithms can optimally exchange information. So in this sense, I am particularly happy that I could win this award with my research on visualizations, which allow humans to use their unique knowledge and experience to solve decision problems in an interactive dialogue with data and algorithms. And I sincerely hope that my research can inspire future work on data-informed decision-making. Personally, the recognition encourages me to continue my own research, where I currently investigate ways to elicit complex preferences from the decision makers' heads to make them available basically for use in interactive analysis or also computational methods.